Okay, so we started the chapter with the phenomena of electromagnetic induction, and the formula of motional EMF was this: VBL sine theta. Before that, the formula of magnetic flux was BA cos theta. Right, students? These are like different thetas, different formulas. Do not forget about it. It's a little different than A levels, right? Okay, next formula we studied was, students, NS phi S is equal to NIP, which was what? Which was the mutual inductance formula. NIP, MIP, right, students? And the next thing we studied was Faraday's law of electromagnetic induction. It was negative N delta phi by delta T, right, students? And then for the self-inductance, we studied this formula where M is the mutual inductance and L was what? Self-inductance. Then, students, energy stored in the inductor was half Li square. Or, students, it was half B, what was that? Yes, here formula. Half B square AL over mu naught. Half B square AL over mu naught, right? And then energy density was what? It was half B square over mu naught, right? So these are the things that we have studied. Okay, now let's go further. Students, you all know about AC generator already, right, students? Okay. So the thing is, okay, now we are going to do it in a little much more like detailed form, the AC generator, right? Okay, students. Right, students? Okay. Alternating current generator. A current generator is a device that converts mechanical energy into electrical energy. Right, students? So, okay. So here we have things in it. Like first we have permanent magnet here, students. And then, students, we have the coil, which we are going to move. Then, students, we have the like slip rings. And then, students, we have the carbon brushes. 1 minute, students. Just give me a minute so that I can make the students standing outside quiet. Okay, students. So, yes. So, students, this is the magnet, you know. This is the coil. Since here is the slip rings, they are made of copper. And since here is the carbon brush, right? Carbon brush. Okay. So yes, they are also labeled in the diagram at the right side as well. Slip rings, wire or loop, magnetic flux or magnetic poles, everything is written, right? Okay, now the students, the formula of the maximum EMF is this. When the sine theta is 1, means the theta is 90. And if we talk about like the EMF which is not maximum, it will be looking like this. It will be looking like what? N omega A B sine theta. Now, from where this formula came, this, you don't know about it. And I think it's not necessary. But if you want, then I can let you know about it, students. The formula was VBL sine theta, right? Okay, then what do? We put this V is equal to R omega. BL remain there, right, students? And what about Yes. Okay, now what do? We separate these things. It is like omega B, and then we have since this R times L. So students, if we talk about the width of the coil, it is like this. Since let's have a look at the diagram. Since here is the width, so where is the radius? The half of it is the radius, right, students? So here is the width W and here is the radius R. So radius R is half of the W, or I can replace this radius R by what? Half of the width, right, students? Okay, then omega B. So this is the EMF, and students, what is this thing? Omega L. Omega L is the area. So WL is the area, right? So the formula will become omega BA divided by 2. So this will be the EMF in one side, right? So in two sides, it will be double of that. Both sides, double of that means it is going to become 2 times omega BA over 2. So it is going to become omega BA. But this is for one turn of the coil. And for n turns, we will be multiplying the formula by n. So it will become n omega A B. So that's the formula. So I just thought you people would be thinking, sir always say that the mathematical proof is not in the syllabus. Yes, I'm still standing on that. It was just some wastage of time. But I wanted to tell you that everything has some background working, right? And you can have the mathematical proof of each and every formula, but they are not needed, right? So students, this is basically the value of E naught or E max. What? E naught or E max. So that's why we write down this formula as this. Theta is represented as omega t. So that's the final form of the EMF, right, students? And these are the diagrams that you already know that at time t equals to 0, this is going to be the position of the coil. So the current is 0, and then time t equals to t by 4. This is how the coil is going to look, and the EMF is maximum. And this is at t equals to t by 2, and this is t equals to 3t by 4. And since this is t equals to 2, capital T, complete time period, right? So that's the diagram of the graphical representation of the alternating current produced by the AC generator. Right? Okay, students. DC generator was not an A-level syllabus. So this is some new thing for you people. Okay. So let me tell you that instead of slip rings, we have commutator. Commutator is also called, students, split ring. What? Split ring. Right, students? So commutator is basically what? It is the split part of the ring. Okay, students? Right. Means in AC generator, we used to use what? We used to use slip rings. That was a full ring. But here, students, it's going to be half ring connected to one terminal and half ring connected to the other terminal, right? Carbon brushes are there. Same. Magnetic field is there, coil is there. So there is only difference between AC generator and DC generator is, students, that AC generator uses slip rings of copper and DC generator uses split rings made of copper, which is also called what? Commutator. And the purpose of this is like the rectifier, like it is going to convert the AC into pulsating DC, right? So this is the DC output of this DC generator, right? Okay, students. DC motor. What is DC motor, students? You already know about it. The formula we use is BINA cos alpha or cos theta for the moment, right, students? Acting on the coil, we have the split ring commutator as well. Again, just like DC generator, DC motor also has this split ring, or we also call it what? Commutator. Right, sure. And then we have this carbon made brush and the same thing. But the principle is definitely opposite. Like there, the mechanical energy was converted into electrical, and here, electrical energy is converted into mechanical energy. Right, sure. Okay. Back motor effect in generators. Back motor effect in generators means, students, that in generators, it means a generator can also act as motor in opposite direction. और दूसरे वाले को क्या कहेंगे? जनरेटर, मोटर. बैक मोटर इफेक्ट इन जनरेटर क्या हो जाएगा? जैसे कहेंगे अ मोटर कैन also be used as generator in opposite direction. ठीक है, मतलब दोनों का काम ही ऑपोजिट है, तो डेफिनेटली फिर हम ये कर भी सकते हैं. नेक्स्ट चलते हैं स्टूडेंट्स, ट्रांसफॉर्मर. यस,